The doors are still there. That is the first fact worth establishing, not reconstructed, not replicated, not described in a surviving text, still there, standing, hinged, and in several documented cases still functional after what historians conservatively estimate to be 2,000 years of continuous existence. We are told they were built by ancient craftsmen using hand tools, stone-cutting techniques, in a labor force organized under centralized state authority. That is the official explanation. It is repeated in textbooks, museum placards, and academic papers with consistent confidence. Here is the technical problem. The Balawat Gates of Assyria, now partially housed in the British Museum, are bronze-banded wooden doors originally standing approximately 7 meters tall. The bronze panels are cast with a precision that archaeometallurgists have noted requires controlled alloy composition and uniform temperature application across large surface areas. The woodwork beneath the bronze shows joinery tolerances that, when measured, fall within margins that modern cabinet makers describe as difficult to achieve without calibrated instrumentation. The official explanation accounts for the artistry. It does not fully account for the engineering consistency across the entire structure at that scale. That gap between what is explained and what is physically present is where this investigation begins. Scale is the first variable that the official record tends to understate. When we talk about ancient doors, the tendency in historical literature is to focus on decoration, the carvings, the iconography, the symbolic content. These are treated as the primary subject of study because they communicate cultural information, religious hierarchy, military victory, political authority, but the symbolic content is not the anomaly. The anomaly is the engineering. The doors of the Karnak Temple complex in Egypt present a specific problem. Some of the original doorframes at Karnak were cut from single pieces of granite, not assembled, not mortared. Single pieces shaped to accept pivoting door mechanisms, with socket holes worn smooth from repeated rotation. Granite, single pieces, at heights that required either scaffolding systems of considerable complexity or alternative lifting methods for which no documentation exists. The pivot sockets themselves are worth examining. They are not rough approximations. They are curved to precise radii that match the door pivot dimensions, ground to a smoothness that reduces friction measurably. This is not decorative work. This is functional mechanical engineering in stone, and it was accomplished before the invention of any tool or machine that historians currently attribute to that period. Egypt alone would be notable. Egypt is not alone. The same pivot socket technology appears in structures separated by thousands of miles and, in some cases, by centuries of historical distance. The Lycian tombs of modern Turkey contain door mechanisms carved from solid rock faces that use the same basic pivot and socket principle found in Egyptian temple construction. The Nabatean structures at Petra, cut directly into sandstone cliff faces, include door surrounds and threshold markings consistent with large pivoting panels, though the doors themselves are gone. In India, the Kailasa Temple at Ellora, carved from a single basalt outcropping downward, meaning the entire structure was excavated from the top down rather than built upward, contains door jambs and threshold channels that archaeologists acknowledge required precise pre-planning before a single cut was made. There is no margin for error in top-down excavation. The doorways had to be planned in their final dimensions before the surrounding stone was removed. The question that the comparative record raises is not whether these structures are impressive. They are. The question is whether independent invention adequately explains why the same functional solutions appear across non-communicating civilizations in roughly similar periods. The official answer is convergent development. Similar problems produce similar solutions. That explanation is reasonable for basic tools. It becomes less comfortable when applied to precision engineering and materials that resist precision. Granite does not cooperate with simple tools. This point is consistently underrepresented in popular historical accounts and occasionally contested in academic ones. But the material science is not ambiguous. Granite has a Mohs hardness of approximately 6 to 7. Bronze, the material most commonly cited as the primary cutting tool of ancient Egyptian craftsmen, has a Mohs hardness of approximately 3 to 4. A material cannot be efficiently cut by a softer material through direct abrasion at any meaningful rate. The conventional response is that ancient craftsmen used harder abrasive materials, quartz sand, corundum, dolerite pounding stones, in combination with softer metal tools to achieve the results we observe. This is technically possible. The debate is not about possibility. The debate is about time and precision. The door socket at the Temple of Seti I at Abydos is hemispherical. ground to a consistent radius across its entire curved surface. Achieving that geometry with abrasive paste and manual labor is not impossible, but the consistency of that radius at the depth of that socket requires either an extraordinary duration of labor to produce a single component or a method of maintaining consistent geometry during the grinding process that is not currently documented. When engineers who specialize in stone fabrication are asked about this, not historians, engineers, the answer tends to include the phrase, "It would take a very long time," more frequently than it includes a specific method. A very long time is not a fabrication method. It is a placeholder. The size problem compounds the precision problem. We are not discussing small doors. The historical record, when it preserves door dimensions, describes structures that dwarf most modern institutional buildings. The ancient city of Babylon, as described in cuneiform records and partially confirmed by excavation, contained the Ishtar Gate, the reconstructed version of which stands approximately 14 meters tall in the Pergamon Museum in Berlin. What is in Berlin is a reconstruction using original glazed brick fragments. The original, by textual account and structural analysis of the surviving foundation, was taller. The doors that closed the Ishtar Gate processional entrance are described in Babylonian texts as cedar wood, bound in bronze, towering above the gatehouse platform. Cedar from Lebanon, transported hundreds of miles. Bronze in quantities requiring smelting operations of industrial scale. Door panels of a size that, when calculated against the opening dimensions, would have weighed in the range of several tons each. The engineering challenge is not disputed. The mechanism by which those doors opened and closed, daily according to temple records, is not clearly explained in surviving documentation. Pivot systems for doors of that mass require either counterweighting or mechanical advantage through leverage systems. Neither is described in the Babylonian administrative records that survive. The records describe the doors in considerable symbolic detail. They are silent on the mechanism. Silence where technical documentation should exist is a pattern in this record. It appears too consistently to be coincidental. Let us be precise about what kind of silence we are describing. Ancient civilizations were not uniformly silent. The Egyptians documented grain inventories. The Babylonians recorded interest calculations. The Romans wrote engineering manuals. The capacity for technical documentation existed. In many areas, it was exercised in detail. The silence is specific. It clusters around construction method, around the how rather than the what. The Ebers Papyrus documents Egyptian medical procedures in clinical detail. The Rind Mathematical Papyrus records geometric calculations with precision sufficient to support complex construction planning. Egyptian administrative texts record labor allocation, food rations, material quantities for large projects. What does not appear in the volume one would expect, given the scale of what was built, is the sequential technical manual. The step-by-step description of how a 40-ton door pivot socket was achieved in granite to the tolerances that the physical object demonstrates. Delve the calculation for counterweight ratios. These documents either existed and were lost, existed and were deliberately excluded from what was preserved, or were never written because the knowledge that produced these structures was transmitted through a method that did not rely on written documentation. Each of those possibilities raises a different set of questions. None of them is comfortable within the standard historical framework. There is a category of structure that amplifies this problem considerably: the monolithic door. Several sites around the world contain doors, or door-like slabs that are cut from single pieces of stone at dimensions that challenge current explanation, not just in terms of precision, but in terms of raw logistics. The Serapeum of Saqqara in Egypt contains granite sarcophagus boxes, not doors, but comparable monolithic stone objects, each weighing approximately 70 to 80 tons, fitted into chambers with tolerances measured in fractions of a millimeter. They did not arrive assembled. They were moved, placed, and fitted in their current locations. The access passages to those chambers are too narrow to have admitted the stones after the chambers were sealed. This means the stones were placed before the chambers were completed, or the chambers were constructed around the stones, or there is an aspect of the construction sequence that has not been identified. Archaeologists acknowledge this is an unresolved logistical problem. No consensus solution exists. Now, transpose that problem to doors. At the site of Tiahuanaco in Bolivia, at an elevation of approximately 3,800 meters above sea level, stone blocks and architectural elements of a scale comparable to major Egyptian construction exist in a location that is geologically remote from the stone quarries from which the material originated. the transport distance, the elevation change, the absence of navigable waterways connecting source to site. These are not disputed facts. They are documented in the geological record. The official explanation is human labor organized at scale. Large teams, ropes, wooden rollers, earthen ramps. This explanation is reasonable at lower elevations and shorter distances. At Tiahuanaco, the same explanation requires assumptions about organizational capacity and logistical infrastructure that would represent one of the most complex pre-industrial supply chains ever documented in a location where documentation of that supply chain does not exist. The structures exist. The supply chain is inferred. The gap between inference and evidence is not small. The question of who the doors were built for is one that archaeology tends to answer in symbolic terms. Temples were built for gods. Palaces were built for kings. Gates were built to communicate power and control access. These are functional answers in cultural terms. They explain the purpose of large doors as expressions of authority and religious hierarchy. But the symbolic explanation does not fully address the dimensional question. The proportion of many ancient monumental doorways is specifically relevant here, at the Temple of Jupiter at Baalbek in Lebanon, a site that presents some of the most discussed engineering anomalies in the ancient world. The remaining temple structure includes column drums and architectural blocks of a scale that dwarfs the later Roman construction built on the same platform. The foundation platform at Baalbek contains individual stones, the trilithon blocks, each weighing approximately 800 to 1,000 tons. These are among the largest deliberately moved stones in the archaeological record. They are fitted into the foundation course with a precision that required planning the final joint dimensions before the stones were transported. The temple built above this platform by Roman engineers is itself massive. But the Romans who built it did not move the trilithon blocks. They built on a foundation that was already there. Roman engineering, which was sophisticated enough to build the Pantheon and the aqueducts, apparently used a pre-existing foundation rather than laying their own. There's no Latin text that clearly explains why Roman engineers built on an earlier foundation rather than constructing their own. The decision suggests the earlier foundation was adequate, or perhaps that moving those stones was beyond what Roman engineering methods could accomplish. If it was beyond Roman capability, the question of whose capability produced it remains open. Return now to the doors specifically, because the temple platform at Baalbek also contains evidence of door mechanisms. The threshold stones at Baalbek show pivot wear patterns consistent with very large rotating panels. The wear patterns are smooth and regular, indicating extended use over a substantial period. The dimensions of the threshold openings, when measured, indicate door panels of a height and width that would dwarf the doorways of any surviving Roman structure. Roman architecture has large doors. The doors of the Pantheon, which survive and are original, are approximately 7 meters tall and cast in bronze. They are among the largest surviving ancient doors in the world. They are visually impressive and mechanically sophisticated. The threshold dimensions at Baalbek suggest doors substantially larger than the Pantheon's. No panels survive. What survives is the stone evidence of what closed the openings, and those threshold markings describe a scale of door panel for which no intact parallel exists in the surviving archaeological record. The evidence for the doors exists. The doors themselves do not. The explanation for what happened to doors of that scale, whether they were removed, repurposed, destroyed, or never completed, is not definitively established. There is a pattern worth noting across multiple sites where large-scale door infrastructure exists without surviving door panels. At Persepolis in Iran, the Gate of All Nations contains threshold stones worn by pivoting mechanisms. The stone jambs still stand, reaching considerable heights. The doors described by Greek historians who visited Persepolis, Diodorus Siculus, Quintus Curtius Rufus, were described in terms of scale and material that placed them among the notable features of the complex. Those doors are gone. The site was burned by Alexander's forces in approximately 330 BCE. Wood burns. Bronze can be melted and recast, but the stone infrastructure, the door jambs, the threshold sockets, the spacing of the openings, these are permanent records of what the doors required in terms of size and mechanical support. When you measure those requirements and then examine the descriptions that survive, a consistent picture emerges. Doors at Persepolis were large enough that Greek visitors, who had seen the Acropolis and the temples of their own culture, considered them worth remarking upon, specifically for their scale. Greeks in the 5th and 4th centuries BCE were not easily impressed by large structures. That they noted the doors of Persepolis in terms of scale suggests those doors exceeded what Greek experience had established as the upper range of normal. The disappearance of doors is itself a pattern that runs parallel to a broader disappearance of the capability that produced them. Consider the timeline of documented ancient construction capability. In Egypt, the peak of large-scale stone construction occurs in the Old Kingdom period, the Pyramid Age. The engineering precision at Giza, which includes not just the pyramids but the associated temple complexes and their door infrastructure, represents a technical peak. After the Old Kingdom, Egyptian construction continues for millennia. But the scale and precision of the very earliest documented period is not consistently replicated or improved upon. The Pyramid of Djoser is impressive. The Great Pyramid is technically beyond it in almost every measurable dimension, despite predating it in some reconstructions. Subsequent pyramid construction shows degradation in precision. This is unusual from the perspective of technological development. The standard model of technological history is cumulative improvement over time. Knowledge builds on knowledge. Skills are refined across generations. What the Egyptian construction record shows in terms of peak precision is not consistent with cumulative development. It is consistent with a capability that was present at a high level early and then gradually declined rather than advanced. This pattern, high capability appearing early and then degrading rather than advancing, appears in other material records. The Roman concrete used in marine construction contains a specific mineral interaction between seawater and volcanic ash that produces a material more durable than modern Portland cement under long-term submersion. This was established by material scientists analyzing the harbor structures at Caesarea Maritima and other Roman port sites. Roman maritime concrete improves in strength over time through ongoing mineral crystallization. Modern concrete does not. The Romans used this concrete extensively. Then Rome declined. The concrete formula was not preserved in usable form. Medieval and Renaissance builders did not have access to it. It was not rediscovered. It was reanalyzed from surviving structures in the 20th and 21st centuries. Knowledge was present. It was not transmitted forward. The capability disappeared with the civilization. If this happened with Roman concrete, a formula that can now be analyzed from surviving samples. The question of what other technical knowledge disappeared without leaving analyzable traces is not answerable with confidence. Return to the question of who the doors were built for. This question is usually interpreted symbolically. The doors of a temple were built to impress worshippers, to communicate divine scale, to separate the sacred space from the profane world outside. That interpretation is coherent and probably partially correct, but the dimensional question persists alongside the symbolic one. In standard architectural practice, ancient or modern, doors are scaled to the people who will use them. Functional doors relate to human scale. A door built for a human being to pass through requires a height of approximately 2 to 2.5 meters and a width proportional to expected traffic. Doors are made larger than strictly necessary for aesthetic and functional reasons. To admit processions, to allow large objects to pass, to create an impression of grandeur. But the scaling relationship between human size and door size generally remains within a recognizable ratio. At several of the sites under examination, that ratio is not maintained at recognizable proportions. The gateway openings at Baalbek, the threshold dimensions at certain Egyptian temple sites, the door infrastructure at Persepolis. When the opening dimensions are measured and compared to human scale, the resulting ratios suggest doors that exceed aesthetic grandeur by a margin that some architectural analysts have noted as difficult to explain purely through symbolism. A door twice the height of a human communicates grandeur. A door 5 or 6 times the height of a human also communicates grandeur, but it simultaneously creates a practical problem. It requires significantly more engineering complexity to open and close on a regular basis, and it scales the architecture away from practical human use. The official explanation for oversized ancient doorways is that they were not intended for regular daily use, but for ceremonial occasions. This is a reasonable explanation for some structures. It is less satisfying when applied to sites where threshold wear patterns indicate regular, sustained, repeated use. Wear patterns do not lie about frequency. Stone wears at measurable rates. The wear at certain ancient threshold pivots indicates not ceremonial use on high occasions, but operational use across many years. There is a final category of evidence that is rarely assembled into a single comparative view. the global distribution of similar door infrastructure technology. Japan contains the Izubutai Kofun, a burial mound in the Asuka region whose stone chamber includes granite blocks weighing approximately 2,300 tons in aggregate, assembled into a chamber with a door-like access structure of considerable precision. The fitting of the stones in the chamber approaches tolerances comparable to Egyptian precision stonework. Japan and Egypt are not historically connected in the period when these structures were built. The conventional explanation is independent development. The technical similarities and precision fitting of large stone elements across non-communicating cultures remain unexplained beyond the convergence hypothesis. Peru contains the site of Sacsayhuaman, with interlocking polygonal stone blocks, some weighing over 100 tons, fitted without mortar to tolerances that prevent a blade from passing between courses. The site also contains evidence of door and gateway infrastructure. The stones show surfaces that geologists have described as unnaturally smooth for their composition and age, smoother than natural weathering would produce, suggesting either an ancient surface treatment or a cutting method that is not currently replicated. The same polygonal interlocking technique appears at sites in Turkey, in the Cyclades of Greece, in parts of Japan, and in multiple locations in South America. These regions are separated by oceans. The conventional explanation for stylistic and technical similarity across non-communicating cultures is either that common problems produce common solutions, or that contact occurred that the historical record does not document. Neither explanation is fully satisfying in the technical domain. Common problems produce similar solutions when the material constraints and available tools are similar. The material constraints at each of these sites differ. The tools attributed to each culture by conventional archaeology differ. The results, in terms of precision and technique, are consistent. What does the evidence, assembled without predetermined conclusions, suggest? It suggests the following questions, which the current framework does not comfortably resolve. Why does construction precision appear to peak early in multiple ancient cultures and then decline, rather than developing progressively? Why is the technical documentation of construction method absent in civilizations that documented other aspects of their technical practice in considerable detail? Why do the same precision techniques appear across geographically and culturally separated civilizations and similar material applications? Why do the threshold dimensions and door infrastructure at multiple ancient sites describe openings at scales that exceed comfortable explanation through human-scale ceremonial function alone? Why does material science continue to identify ancient construction results? Roman concrete, Egyptian granite tolerances, pre-Columbian stone fitting that cannot be straightforwardly replicated with the tools conventionally attributed to those cultures? These are not rhetorical questions designed to imply a specific alternative conclusion. They are questions that the physical evidence generates when examined without the assumption that current answers are complete. The institutions responsible for studying these structures, universities, museums, archaeological bodies, perform careful and genuinely important work. They document, they date, they analyze, they preserve. What they do less consistently is aggregate these technical anomalies into a framework that demands explanation. The granite tolerances at Abydos are noted in specialist literature. The threshold where at Baalbek is documented. The logistical impossibility at Tiahuanaco was acknowledged in field reports. The disappearance of Roman concrete knowledge is studied by material scientists. But these observations exist in separate disciplinary silos. The granite specialist does not typically compare notes with the Andean archaeologist. The materials scientist analyzing Roman concrete is not in regular dialogue with the architectural historian examining Persepolis. When the evidence is brought together across these silos, the pattern that emerges is consistent enough to require more than coincidence and more than convergent development as an explanation. The official explanation, in each individual case, is coherent in isolation. In aggregate, across materials, continents, and centuries, the isolation of each explanation begins to feel like a structural feature of how this subject is approached, rather than an accurate reflection of what the evidence contains. The doors are still there. Some of them still turn on their pivots. The stone is worn smooth from use, not display, use. The scale of the openings they closed is recorded in the dimensions of the frames, the depth of the sockets, the width of the thresholds. The people who built them understood material properties, load distribution, pivot mechanics, and precision stone fabrication at a level that produced results still visible today. In some cases, those results cannot be straightforwardly replicated with modern methods without industrial machinery that the builders did not have. According to the conventional record, The technical knowledge that produced these structures is not present in surviving documentation at the level of detail that the structures themselves require. Either it existed and was lost, or it was transmitted through channels that have not survived, or the conventional reconstruction of what tools and knowledge those builders possessed is incomplete. Those three possibilities are not mutually exclusive. They may all be partially true. What they share is an implication that the boundary between what we know and what we do not know about the ancient world's technical capability is not as clearly established as institutional. Confidence in the standard narrative suggests the civilizations that built these doors, whatever they were, wherever their knowledge originated, are gone. The administrative records, the temple hierarchies, the labor organization, the political authority that commissioned the work, all gone. What remains is the stone, the socket, the threshold worn smooth by a door that no longer exists, closing on an opening that still does. The opening can be measured. The door that fit it cannot be recovered. The method that produced the socket cannot be demonstrated from surviving documentation. There is a gap between what was built and what we can explain about how it was built. That gap has been there since these structures were first studied by modern scholarship. It has not closed. In some respects, as material science and precision measurement have advanced, it has widened. The structures are older than the explanations given for them. The explanations have changed over time. The structures have not. The doors they built are still standing. What we do not know is whether we have correctly identified the civilization that built them, the tools they used, the knowledge they possessed, or the beings those doors were scaled to receive.